All right, so no questions on homework for 6-8? Anything? All right. So in 7-1, what we're going to do is we're going to discuss the topic that leads us into the quadratic formula. How many, show of hands, how many of you know the quadratic formula already from middle school, or have heard of the quadratic formula, or used the quadratic formula? Maybe you don't have it memorized, but you've at least used it before at some point. Okay. So this will lead us into where the quadratic formula actually comes from. You were probably just told the quadratic formula at one point: x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So you're told that statement, but maybe not shown where it comes from. So today we're going to go over where that actually comes from. Take a look at this first. We've recognized that if we have the ability to factor an equation, we can easily find the roots of that equation simply by writing out the factors and using what we call the zero product property. Clearly here we have x minus p and x minus q. Either of those factors could be 0. We've said this all along. If you have 3 factors, you're going to have 3 roots. The problem is this. If I can't factor, how do I get the roots? And a lot of people jump right to the quadratic formula, which definitely works. Absolutely. And some people even try to graph, which works if the roots are real. If the roots are imaginary, graphing will do you no good. The graph will just indicate to you that the roots are imaginary. It won't tell you what they are. Using completing the square is another method like quadratic formula that allows us to solve an equation. So if we look at the combination of these two forms, where we're looking at something where it says x squared equals r, but thinking about the factor form, we're going to take a look at these equations in a moment and see how we progress from one step to the next, showing where completing the square comes from. So let's do part A first. Part A first. What do I do to solve part A? And be careful, there's an easy way and there's actually a much more difficult way. Part A. And if part A troubles you, think about this first. What's the answer to that? What's the answer to x squared equals 5?
5 to the square root of 5.
Or?
Negative.
Good. Because you're solving an equation, right? We look at not just the principal square root, but the negative root as well when it's an equation. So that is obvious, right? You square root both sides because you had x squared. Look at part A now. It's very similar, right? Except for that minus 2 in there. Forget that minus 2 for a second. If you need to, cover this up. Cover the minus 2 up. If you just had x squared equals 3, what would you do? What would you do? Square root it. So go ahead and square root it for part A. So again, you're square rooting both sides for part A. Remembering that when you square root in an equation, you get plus or minus. And then just simply get rid of the 2. How do you get rid of the 2? You add it. Okay, it's negative. Let's add the 2 to both sides. Anybody want to give me an idea of how I should write this, though? How should I write my answer? For those that have seen the quadratic formula, this should be somewhat familiar, your answer. What should the answer form look like? How would I write my answer for this? I have plus or minus root 3 plus a 2. How do I write that as one thing? No one? How do you add 2 to a plus or minus?
Oh, you have to do 2 all answers.
You can do it that way. You can write it twice. Go ahead.
And then x equals 2 plus 3, x equals 2 minus 3.
You can write it like that. That works. I agree. Or you can write it as one answer as 2 plus or minus root 3. Okay? So what am I getting at? I'm getting at this. Ready? When you move this number right here over to the right-hand side, so again, when you move this number right here over to the right-hand side, you need to remember that this is best placed in the front. Okay? Do not place it over here, please. Because then you're going to have plus or minus root 3 plus 2. It confuses people. It confuses yourself. You're going to see with the quadratic formula that your answers are usually written in some sort of number plus or minus another number for the quadratic formula. Okay, that's where that comes from, the plus or minus in the quadratic formula. Part B is pretty easy also. Part B is pretty easy. Do that, please. Treat it the same way, please. So start by square rooting both sides. And then keep going. Eight is really 2 root 2. So you should simplify radical 8, please. Look at my final answer, obviously. I'm not going to write it all over 2 if I can divide this by 2 anyhow. So I divided the 2 in the front here by that 2 to give me just radical 2. And then the 5 gets divided by 2 there. So far, so good? Pretty straightforward, I hope. How about the next one? How about part C? Can somebody talk about what's going to happen with part C before they do it? Again, before you do it, tell me what's going to happen with part C, or tell your classmates. It's not on the board, I know, it's on your notes. What's going to happen on part C? Well,
It's going to be a new copy.
very good. Your answer will be imaginary. Your answer will be imaginary because of the negative radical. Square root of 4 is 2. Bring out the I, you have plus or minus 2i. How do I get rid of this one now? Right here. How do I get rid of this one? Where do I put it? Where do I put it?
Subtract 1.
Subtract 1 from both sides.
Yeah.
So what does the answer look like, Alex?
Plus or minus 2i minus 1.
Okay, but how should I write it? Remember, we've been writing it differently.
Negative 1 plus or minus 2i.
Very good. Okay, and it's not very intuitive because you want to subtract it. You want to put it after it. I agree with you. It makes more sense to write it as plus or minus 2i minus 1, showing that you're taking that away. But remember, when you write complex numbers, it's always the real part plus or minus the imaginary part. Okay, remember A plus BI form from yesterday? Okay, so you're going to continue to do this. You're going to take the negative 1 and say, I'm adding negative 1 over here. Well, just take the negative 1 and put it right in front. It's the same thing as if I move this negative 1, the whole thing, over here. Okay, so again, I could have moved this negative 1, the entire thing I'm circling, over here, but we write it in A plus BI form. The fourth one, anyone recognize the fourth one? Take a look at it. In the past, I would have told you to do what to solve this? What would I have told you to do? Well, okay, but before you factor, what would I have told you to do?
Move everything to one side.
I usually would tell you set A equals 0, right? Move everything to one side. So I would normally say add the 5 over, you'll get a 9 there instead. But I'm not going to tell you to do that, actually. I'm going to tell you to do what Will just said, factor it first, which is not very intuitive. Normally, right, we've said move this over, get a 0, then factor. It will not be able to be factored if you move this over, though. Try it. Make that a 9. What numbers multiply to 9 and add up to negative 4? Nothing. It's not going to be factorable if you move the 5 over. So just factor the left-hand side. What does it become when you factor it? Yeah, x minus 2, x minus 2. which is, as Will said, x minus 2 quantity squared. And now, part D looks just like part C and B and the one before it. Okay, and whenever you have something squared equals a number here, you can use this method. And this really is completing the square, but I'll talk about how to do this with any equation you could do this with. So our final answer here, if we take a look at the radical of the square root of negative 5, we write it as I root 5. Again, you could switch the order of these so it's in a plus bi form, but the I sometimes at the end of the radical looks like it's underneath. So 2 plus or minus I radical 5. Okay, I radical 5. So let's take this idea. This first example is just to practice. And let's bring this and make a general overall statement. The statement I can see, or can anybody recognize something here? Or can you make an if statement, if this, then this? So for example, if I gave you a quadratic, look at part D, please, but also look at what I'm going to write at the bottom here. If I gave you this. Okay, if I gave you that statement right there, could you do what we did in part D with this? Would that work? Can you factor x squared minus 5x plus 7? No, you can't, right? Even if you move the 4 over, this becomes a 3. 3 and 1 gives you 4, not 5. So that's not going to work either. So this is not factorable at all, right? What's written in black? But if I could somehow get this to look like the top, where I could factor, it would be ideal, wouldn't it? I could factor it into the same double bubble or the same factor as x minus 2, or whatever this is. Same thing I could do is right here. The thing is, it's not written that way. The C value is what's screwing everything up. The C value, right here. That's what messes everything up. So what we're going to need to do is we're going to need to analyze this and say to ourselves, all right, you know what we have to do? We have to recognize based on what's here, we need to change this to something else. And 5 is a bad example, I guess. We can do that. We will. But it gets a little complicated with an odd number. Let me pick an even number just for the sake of right now. Okay, so let's make that 5 an 8 instead. If that 5 were an 8, what should C be? What should C be so that I could factor this into something with the same factors? Change the value of C so that this can be factored with the same factor written twice.
16.
Why?
Because 4 or negative 4 would multiply together, we get positive 16, and then added together, we get negative 8.
Yeah, she said 16. Well, what's half of this number, everybody? What's half of this?
4.
Square it. That's the technique. That's all you really have to do. Take half of this number. This is what you actually did in your head, because you're like, all right, x minus 4 would give me a negative 8, right? And minus 4 times minus 4 is 16. So whatever this number is, assuming there's no coefficient here, we get rid of this coefficient first. If there's a 2 here, divide everything by 2 to start. Okay, assuming there's a 1 or a unity coefficient, leading coefficient, have b, have it, square it, and make this that number. Does that make sense? So if I need to make this a 16, what do I have to add to this side? So what I have to do to this side, also add 9. So add 9 to both sides. We'll go over the steps. I have all the steps written out for you in a minute. So please, again, add 9 to both sides. That makes that 16. Left-hand side just becomes 13. And now you can go through all the steps of factoring. That's x minus 4, x minus 4. Square root it. And add the 4 over. two roots because it was x squared. Those roots happen to be irrational in this case. They are both irrational roots. And they're binomial conjugates. 4 plus root 3, 4 minus root 3. I know you've seen a lot of that lately. It's not going to go away. You'll see a lot in math with conjugates. They occur a lot. They always come in pairs. Okay, you're going to see that happen. So let's take that idea that we just went through a moment ago, okay, and generalize this with some steps. Think example 2. Yeah. Skip example 2 because that's literally what we just did. I just changed the numbers up, okay? What would example 2, by the way, what would you have to add, just so we know? What would C have to be for example 2 right here? What should C be? 20? Yeah, add 22 to get to 25. Half of 10 is 5. Square that, you get 25. So you would start by adding 22 to both sides for this kind of a problem here. And then solve. Okay, I'm going to leave that for a moment just because we just did a problem just like that. Okay, the general steps are as follows. First, you can just list these if you want. You can put an example if you want along the side, or you don't have to if you don't want to. Okay, so the general steps that I gave were as follows. I would recommend moving C over at first. Okay? Either you can add that number or just move C over. So for example, for the first step, I'm going to put an example up, but I want you to write these words out. So move C so that it's by itself on the right-hand side. And here's what I mean. Let me show you. So here's our example, let's say. Hold on, let me think. Let's say this is our example right here. Okay, move C to the right-hand side first. It's the same thing we did. I'm just going to show you a little bit of an easier technique to get rid of C. Now, once you move C over, have this square it, but you have to have a 1 value for A. So what should I do as my second step there from steps 2 to 3? What does it look like from 2 to 3 if I want to get rid of A? Well, so what does it look like?
X squared minus 8x equals -15.
Okay. So from step 1 to 2, you're going to move C. From steps 2 to 3, divide by A. Okay, move C over, divide by A. Now fill in the missing blank by adding B over 2, the new B value, whatever that is. Have B and square. In this case, B was 8, so I take half of that, which is 4, squared, which is 16, put a plus 16 there, and add it to both sides. Have B and square, and add to both sides. And then the next step is just a factor. Something interesting to notice. Please don't actually try and factor this. Take a look where I'm pointing, please. Don't try to actually factor line 4. It's always going to be x minus half of whatever b is, or x plus half of whatever b is. Whatever you got when you have the b value, you then square it and put it here. Half of that b value will always appear here. Always, always, always. It's always going to be in that location. And then just go ahead and solve. The square root of 1 is just plus or minus 1. Am I going to write 4 plus or minus 1? Am I going to leave my answer like that? Does that make sense to leave an answer that way? What should I write my answers as? X equals, 5 and 3. Okay, if it's obviously irrational or imaginary, yes, you leave it as a conjugate. You leave it as 2 plus or minus radical 7, or 2 plus or minus 3i. But when it's an integer solution or a rational solution, please combine like terms. Okay, please combine like terms. So it's up to you, by the way. That first step with move C, your book recommends that. So I remember when I taught it the first year, I told all my students, move C over so that there's an empty spot here to remind you to have this and square and fill in that spot. That works. Or you can do kind of the way we did in the beginning. You can still just have this, square it, say, okay, I need 16, I have 27, which means I needed to take away how many from that side? 12. Take away 12 from the 3 at the top, you end up with negative 15 still. Okay, so if you want to do it that way, where again, you take a look, you have to divide by 2 first to get rid of this. So if you divide by 2 first, you end up with some decimals there, but then you're going to have this and square it. It'll be a decimal value. You'll still end up with a 15. But the idea is that you can move this over first, or you can move it over afterward. It doesn't really matter either way. Okay, you could try both either way. This. Try example 3 on your own, see if you can get through example 3. And again, for a problem like this, if you don't want to move the C value over, you don't have to. You can just have B, square it, and realize, okay, I need a certain number, so subtract or add something to get it to the number you need. I'll write up both ways to do this, either moving C over or not. So that's one way to do it on the left, when you move C over. The answer's not there, but the step is there. And on the right, you could do this. You could say, well, I need to get 9, right? And I have 13, so let's subtract 4 on both sides. So this ends up becoming which is the same thing as this, really. So you get to the same step by the third line. But if you want to move C over first, you can. If you don't want to move it over, I don't care. Either way works. All right? Just make sure A has no coefficient. Or make sure A is 1. After this, it's always going to be half of whatever. I don't have to keep writing this, actually. It's the same answer from this point on. It's always going to be half of whatever the B value is now. B is now 6. Half of 6 is 3. That's got to go in that spot. Okay, that will always, this 3 here will always be half of whatever B is. And please leave it that way. You do not need to write it as two separate answers. Leave it as a complex conjugate. How do you know if you're right? How do you know if you're right? Any idea? Once we do the quadratic formula, you can check with that. But if you wanted to check this, you can't look at the graph, because when you graph, the roots are the x-intercepts. But these can't be x-intercepts. They're not real numbers. So this indicates that the graph of this would float above the axis. Imagine your axis, right? The graph would be floating. Again, whenever you, and we'll see this later in the chapter, in chapter 7. Whenever you get imaginary roots, it means it's doing this, or maybe it's like down here, okay, like this, but it will not have any x-intercepts at all. Whenever the intercepts or the roots are imaginary, you cannot have x-intercepts. Remember, the x-intercepts are the roots. They're the same thing. We learned about that earlier this year already. Since they're imaginary and the x-axis is a real axis, it can never cross the x-axis. Okay, so imaginary roots are indicative of a graph that has no real x-intercepts. So how would you know if you're right to check? Because you can't check with the graph there. What could you do, though, if you really wanted to? How could you always check an answer? It'd be really tedious with this one, but you could always do it. Yeah, plug it in. Take 3 plus 2i, plug it in here and here, and see if it works at the top left there. And then take negative 3 minus 2i. But you have to plug them both in. Sorry, negative 3 I said there. Negative 3 plus 2i, plug that in both spots. Check it, it works. Then go to negative 3 minus 2i. They'll both work for this. Okay, try the last one on your own, please. Don't forget the a value. Don't forget the a value, please. Hey, remember, go back to your steps if you have to. Move C over to start. All right, move C over to start it. Then go ahead and divide by A. Then take half of the new B and square it. So if you're getting tripped up with the fractions here, please be very careful with your math. Those fraction skills need to be good. What's half of 5 halves? How do we do that quick for those that have been struggling? What's half of 5 halves? 5 fourths. When you want to find half of something, double the denominator. So double the denominator of 5 halves becomes 5 fourths. Square 5 fourths. What does that become? Jen? Yeah. 25 over 16 you have to add. It's not an easy problem at all. Again, half of 5 halves is 5 fourths. Square 5 fourths to give you 25 sixteenths. And then you can say, how do I know how to factor this? I gave you a trick earlier. I told you that the factoring will always be x minus half of the b value. Quantity squared. Well, what's half of 5 halves? Again, have this value right here and square it to get this. So take half of this and place it right there. Okay, again, whatever half of b is that you squared to get this new c value, that half of b also goes right there. Will always work out. You can check it if you don't believe me. Okay, will always work out. On the right-hand side, I need a common denominator. I'll write 3 halves as 24 sixteenths, which together become 49 sixteenths. That's convenient. Why is that convenient? James? It'll square root, right? So make sure to square root both sides here. remembering plus or minus on my answer there. And then move the 5/4 over as a negative 5/4 in the very front. And again, look, your answer is rational. You should combine like terms. So you can have negative 5 plus 7 over 4 and negative 5 minus 7 over 4. Negative 5 plus 7 will give me a 2. Divided by 4 will give me 1/2. Negative 5 minus 7 is negative 12 over 4, or negative 3. So the answers that you get for this one are going to be rational solutions, because this was a convenient perfect square. Okay, 49 and 16 were perfect squares, which gave you a rational answer here for your solution. If you got that and you're good to go, start on the homework if you want to. I think you do have a few minutes. What time is the period over on this day? 1? Yeah, you have about 10 minutes. Get started. If you struggled and you're confused, please raise your hand. I'll come by. We'll go through another example together. Or maybe I can watch you do an example and look for any issues you're running into. So if you feel like you're good and you're confident, open up an example for the homework and try it. Please practice it. Okay, take the time now to practice now. A, you get your homework done. B, I'm here. So if you have a question on the homework you're struggling on, you can ask.
Chapter 7.
Oh, no chapter 7. Hold on, let me put it in. Thank you. Usually that's James that gets to tell me. She stole your thing.